Okay, there's 5.3b, and this is our problem, our matrix we're trying to solve, and this is the form we're trying to get it into. So let's get started. Now, just to kind of give you an idea of what this is we're eliminating variables. Okay, we're eliminating in this one here, notice that we have no x's, no y's, and we have one z, and this z will equal this number. So remember, systems of equations, you eliminate the letters until you get down to one letter, and then you back substitute to get your answer. So what you're going to do is you're going to find out what number z is. So if this is 1z, it will equal some number, let's say 4. So 1z equals 4, because remember, this is your x column, your y, and your z from your original problem. So you got rid of your x and your y, and you're left with 1z. So z equals, let's just make up a number, let's say it's equal to 4. So z equals 4. Now we can plug that 4 that we got here in here, because that's my z column, because 1z equals 4, so this number here would be 4, and this would be my y. Y, say, plus 4 equals a number. Now we can find our y value. So now we have our our z value and our y value. We put those numbers in here and here, and we can find our x. So what we're actually doing is we're rewriting this in such a way that we can find one variable, then the other variable, then the other variable, and this one just represents how many x's, how many y's, how many z's we have, so that we can solve our problem here, if that makes sense. So again, we're finding what this equals, plugging it in here, finding what this equals, plugging both of them in here, and then finding out what our x equals. And then we've got all three variables found. Alright, so the first step, I'll try to make this as uncomplicated as possible. We'll see if we can do this. The first step is to change rows around or multiply or do what we can so that each number underneath here, okay, so each number underneath this number is a multiple of this number. So if this is a 2, we'd want this to be a 4 and an 8, a multiple of this first number. Alright, or the ideal thing would be if we could just automatically get this to be a 1 here. So I'm trying to change this 2 to a 1. Okay. Or maybe not even change it, but get it to be a 1. Now remember, in systems of equation, it doesn't matter where these rows occur. It doesn't matter if I switch rows around. So that's what I'm going to do first, because I see I have a 1 right here, and I need a 1 there. So what I'm going to do is I'm going to move that second row to the top. Okay? And then I'm going to move the other row just down, the first row. I'm just going to switch them around. And you can switch these rows around. It doesn't matter. It's not like you're adding or subtracting or anything. You've just got these rows, and it's kind of like a puzzle. You're just trying to switch things around. Alright, so now what I've got is I've got a 1 there, which is what I want there. Yay! I don't care what these numbers are, but I wanted that to be a 1. Now look here. I need a 1 here, and this is a negative 1. Well, that's good, because that's real easy to fix. And I've already got a 0 there, and that's good. So I need to change these two to zeros, this to a 1, and this to a positive 1. Okay, so a key thing that I've discovered, and maybe it doesn't work for everybody, is I try to get these numbers to be zeros first, and then I start working on these to be 1s. Okay, so let's go ahead and change this to a 0. Okay, so this is where it gets a bit tricky. Alright, so I want this to be 0, right? So if I add this to this row, if this were a negative 2, this negative 2 plus 2 would be 0. So what I'm going to do is I'm going to multiply this entire row here by negative 2, so that I get a row here that's negative 2, or I get this to be a negative 2, so when I add it here, this row here, this becomes a 0. Negative 2 plus 2 gives me a 0. So the row I'm trying to change changes. The row I'm multiplying by remains unchanged. So this is what happens here. This remains unchanged, and this is where a lot of it I don't know, I guess I kind of do it, a lot of it in my head, because it's really hard to write everything down. So that's going to be unchanged, but it's actually going to be multiplied by -2 in order to change this row. Okay, so if I multiply -2 times 1, I get -2. -2 plus 2 is, and we'll do this in red, is 0. -2 times -2 is 4, minus 1 is 3. -2 times -10 is 20, plus 4 is 24. -2 times -6 is positive 12, minus 3 is 9. So again, see what happens. The row that I multiplied by stays the same, but the result of multiplying it by added to the second row changes the second row to that. Okay, so this one changed by multiplying it by -2 will give, added to the second row, gives me the second row. Now let's look at the third row. I want this 3 to be a 0. Well, in order for that 3 to be a 0, let me get some green up here. If I multiply this top row by a -3 and add it to this 3, it will become 0. So again, I'm going to leave this top row alone. It's not going to change at all, but I'm going to distribute this -3, add it to this, and then that answer will go here. So -3 times 1 is -3 plus 3. -3 times -2 is 6. Plus 0 is 6. -3 times -10 is 30. Plus 4 is 34. And -3 times -6 is 18. Plus 7 is 25. Now, if you remember earlier, I said that the number below here needs to be a multiple of this number. And that's so that I can multiply this by a number, and this number here will be the opposite of whatever number I'm doing here, so that when I add this to this, it will always cancel out to be 0. Okay? And so now I have two zeros here. So let's try to get this to be a 1. Okay, this is pretty easy to get to be a 1, because if I look here, I got a 0, a 3, a 24, which is a multiple of 3, and a 9, which is multiple of 3. If that's the case, then that makes this real easy to make some changes here, because all I have to do is divide each one of these numbers by 3. I'm basically reducing a fraction. So I'm going to change this to a 1, this to an 8, and this to a 3. I'm just dividing each of these sections, and this then becomes a 1, which is another thing that I want here. So let's go ahead and write this matrix as a 1, -2, -10, -6. Okay, so remember, nothing changed here. And we'll make this a 0, a 1, an 8, and a 3, and we'll leave the bottom row alone. So if you can reduce a row, if you can make one of these a 1, see, we got this a 0 already, so that was good. So then we just reduce this down by taking a third, or whatever part of this we have to do to get it to be a 1. If this were a 6, we divide each one of these by 6, and that would make that a 1. Alright, so that gives me a 1, 1, a 0, 0. So now I only have to change these two around. Alright, so this is going to be pretty easy to change, because 6 is a multiple of 1. So I'm going to multiply this entire thing up here by a -6. So let's put a -6 out here. And remember, when we multiply it by a number, this row never changes. We take this, distribute it, add it to this row, and this is the row that changes. So let's go ahead and do that. This is very, very confusing. I know that I always dread teaching matrices, just because I just stress out that I'm having a hard time explaining it right. Okay, so remember I said this is going to stay the same, but let's go ahead and multiply. Negative 6 times 0 is 0. 0 plus 0 is 0. Let's use a different color here. Let's use green so you can see what changes. Negative 6 times 1 is negative 6 plus 6, 0. Negative 6 times 8 is negative 48. Plus 34 is negative 14. And negative 6 times 3 is negative 18 plus 25 gives me a 7. Okay, so notice what happened here. All of that work was to change the 6 to a 0. Now we're going to work at changing that, negative 14. So we want that negative 14 to be a 1. So we're going to multiply this whole row, or by 1/14. So just like we multiplied this row here by 1/3 to make that a 1, an 8, and a 3, we wanted this to be a 1. We want this negative 14 to be a 1. So we have to multiply the entire thing by, let's get a bunch of this stuff. Some of this stuff, let me just move stuff. All I want is this right here, so I'm going to get rid of everything else except that. Okay, so I just moved everything out of the way, and this was our final matrix that we're changing that negative 14. So what I'm going to do is I'm going to multiply the entire thing by negative 1 over 14. That makes this a 0, this a 0, this a positive 1, and this a negative 1/2. So let me go ahead and rewrite this with that bottom row changed. Okay, so there is my matrix with my main diagonal right there, all ones, everything zeros here, and I don't care what these are. So let's go ahead and write this as a system of equations again. So we have 1x minus 2y minus 10z equals negative 6. The second row is 1y plus 8z equals 3, and our third row would be 1z equals negative 1/2. Alright, so I know z is 1/2. So I'm going to take this negative 1/2 and put it here, and that'll find me my y. Once I find my y, I plug that answer here, my negative 1/2 here, and I find my x. So that gives me a chance to find all three of the variables that I was looking for. Okay? So I have a triple, which is x is 3, y is 7, and z is negative 1/2. Alright, so what matrices do is it gives you the chance to find one variable, and then you plug it in here with a two variable equation to find this variable. So now you have two answers, and then you plug it into the next one that gives you a chance to find, putting a number here and a number here. You're still only having one variable here. You can find out what the x is. If there was 4, you'd have 3 variable numbers here, and you'd go to the next one to find the fourth answer. So this is a triple, so we have 3 answers there. Alright, so what we just found, we just solved this using the Gaussian elimination with matrices. Now the last matrix that I have right here that is in the proper form is called row echelon form. Okay? Row echelon form. So in order to be in this form, there are certain rules you have to follow. Middle of page 465. If a row does not consist entirely of zeros, then the first non-zero element in the row is a 1. Right there. For any two successive non-zero rows, the leading 1 in the lower row is further to the right than the leading row in the other one. See, this row here is further to the right than this. This row is further to the right. All of the rows consisting entirely of zeros